1,400 light-years separate Earth from the strangest star in the sky. The light from this star flickers, like a giant neon sign drifting through the constellation Cygnus. After the star's dim intervals, which last for days or weeks, it brightens again. No other star acted this way. No observation could explain its behavior. That is, until now. A 200-strong team of scientists says it has arrived at an answer, thanks to an astronomy project crowd-funded on Kickstarter. The culprits are not aliens, as some people have speculated, but probably a cloud of dust, each particle less than a micrometer across. Combined, these dust particles coalesced into one of the biggest question marks in recent astronomical memory. In 2015, astrophysicist Tabitha Boyajian published a paper describing the starlight dips. The brightness diminished by 20%. According to observations from the Kepler Space Telescope, planets block starlight when they pass across stars, like a hand waved in front of a flashlight. But even an object as huge as Jupiter can reduce a star's brightness by just 1%. Other natural explanations were raised and dismissed. It truly is something extraordinary, said Tyler Ellis, a PhD student, who, along with Boyajian, works at Louisiana State University and studies this star and others. The star, a yellow-white dwarf labeled KIC 8,462,852, was unusual enough to get a nickname, Tabby's star. After Boyajian, Tabby's star earned its own Reddit forum. And the star was so curious that Jason Wright, an astronomer at Pennsylvania State University, floated the most exotic explanation available to astronomers: aliens. Perhaps extraterrestrials had constructed a titanic array of solar panels around the star, a hypothetical concept proposed years ago by physicist Freeman Dyson. The construction project would, in theory, diminish a star's brightness in a way consistent with observations of Tabby's star. But when astronomers with the search for extraterrestrial intelligence aimed their radio telescopes at Tabby's star, they heard no signs of life. Meanwhile, Boyajian and her colleagues wanted to go beyond the Kepler data and watch the star dip in real time. They predicted the star would dim on a 750-day cycle, but, to be sure, they needed to continuously collect images each night, in a variety of ranges across the light spectrum. Kepler is not equipped for sustained observation. The only facility that specializes in this is a private facility called the Las Cumbres Observatory, Boyajian said. A public Kickstarter campaign collected the necessary $100,000 to purchase telescope time, and the hunt began through the lens of the California telescope. When the star began dimming in May 2017, astronomers sounded the battle cry, "Tabby's star is dipping," observed Boyajian wrote on Twitter. They nicknamed the May dimming sequence LC, a pun on LC, for light curves, as well as the telescope observatory's initials. Between May and December 2017, the star's brightness dimmed 3 other times, each dip lasting several days to weeks. The scientists probed the LC sequence in multiple color bands. "We had blue light, red light and yellow light," Boyajian said, "a broader range of light than Kepler's previous observations. Whatever substance exists between us and Tabby's star blocks more blue light than red light," as Boyajian, Ellis, Wright and other researchers reported in a study published in the astrophysical journal Letters on Wednesday. Planets cannot explain the dips. If you have something that is completely opaque like a planet, you would expect all the colors of the light to be blocked out at the same levels, Boyajian said. Likewise, the discovery also rules out alien industry. Dust is one of the few explanations this observation does not eliminate. The selective absorption of blue light has to point to dust, Ellis said. Certainly dust is the culprit. Very small particles could block blue light's shorter wavelengths while allowing red light, which has longer wavelengths, to escape. It has the typical signature of dust, Boyajian said. Yet even in space dust, there is mystery. If it is dust, the dust cloud has not spread far beyond its point of origin, the authors noted in the paper. A ring of dust around the star would constantly block starlight rather than dim light in bouts. And the amount of dust needed is more than Tabby's star should produce. It is a main sequence star, middle-aged, so to speak, neither forming nor dying. The star could be, essentially, burping out this material, Ellis said. But that's way too much activity for a star of this type. Even with a natural cause for its dips, Tabby's star has not lost its exceptional status. Nor does this work eliminate some other, unknown possibility that astronomers have not thought of yet, Boyajian said. "We are not done," Ellis said. "We are certainly not done with this star yet. Read more. The weirdest star in the sky is acting up again. No radio signals from that alien megastructure yet, but scientists are listening. How will humanity react to alien life? Psychologists have some predictions.